All right, 9.8, factor polynomials completely. So obviously we've done factoring with like the special types with the difference of squares, perfect square trinomial, that's what we did Thursday and Friday, if I remember correctly. We've also just done factoring by like the arch method. We've done factoring where there's like a 1 in front, so we were just basically finding the factors. It still in a sense was the arch method. We've done a little bit of like pulling out the greatest common factor. But a couple other things that are kind of going to be in this section, it's not just going to be like explicitly telling you like what like way to do things. It's going to just say to factor. And so we may be getting things that are already like they've already done the arch method too, and they've factored something out, but they haven't rewritten it. We may be doing that. We may be finding the greatest common factor. We may be factoring by grouping. Which you basically have to have 4 terms to do that. So there's all different methods that we're going to be using this, but basically we want it factored to the point that it can't go any farther. And so just jumping into examples here, we've got number 4, 5y times y plus 3 minus 2 times y plus 3. So these things here match. So we take the other stuff that's left over and we write it one time, or we write it and the other stuff one time. And so this is basically that they've gone to the point where they have factored out a common factor, more or less, for us, and we're just doing the final step. So this would be 5y minus 2 times y plus 3. And that's factored completely. Let's see. 8. 7c squared times c plus 9 plus 2 times c plus 9. So again, these two parentheses match, so I write that once. The stuff outside is getting written together in a parenthesis, so I've got 7c squared plus 2 times c plus 9.
Do we need to like fully solve it out or no?
This is factoring.
Oh.
10. Y squared times y minus 4 plus 5 times 4 minus y. So what's different about this one?
It's not the same.
They are not the same.
They're not the same, but can I do something to make them the same?
Yes.
What?
You like take out a negative.
Yeah, so I take out a negative. I usually will from the second one. So I'm going to take a negative out of this one. So that's going to be negative 5 times. Now this will make this negative 4 plus y, or I can write this as negative 5 times y minus 4 if I want to swap the term order so that it looks exactly the same. Either of these would be equivalent to this, so it doesn't really matter. But and then I've got the y squared times y minus 4, of course. Minus 5 times y minus 4. So again, those parentheses now match. I write them down once, and then I've got y squared minus 5. So I've got, that's weird, y squared minus 5 times y minus 4. So obviously on those ones, where they're not in the same order, we've got to do an extra step basically. But that's all that is really changing about that. All right, factoring by grouping. So these ones where they're going to give us 4 terms, we're going to group them in sets of 2 and factor things out. We're factoring completely, so obviously our hope is that we can get it down to this. This would have been something that's already been factored by grouping, and so they're kind of just like working us along as we go. So 14, I've got y cubed minus 9y squared plus y minus 9. So this is, they've done the arch method for us already, basically. Obviously, in this situation, there's a cube term that wouldn't look exactly like this, but just for the mindset, that's kind of where we're at. So I group things in sets of 2. I could do this with 6 terms. Like, I can do this in different ways, but I've got the first 2 terms, the last 2 terms, and so I'm looking for what's the biggest thing I can take out of that first group. Y squared, and that leaves me with y minus 9. What about this one? A 1. So then that I have y minus 9. Now it's important that we write the 1 so that we don't get confused when we go to rewrite this, because now these parentheses match. So I've got y squared plus 1 times y minus 9. And so that would be factored completely. Let's see, 18. 2, I'm changing the variable because they're using s and it's confusing. 2x cubed minus 3x squared plus 18x minus 27. So I'm grouping the first 2, last 2. What can I take out of these first 2?
1x2 or
just x squared. And so that leaves me with 2x minus 3. Now what can I take out of this grouping?
3.
Can I take something more than that out?
9.
9. So I want to take out the biggest thing possible. So I'm taking out a 9. That leaves me with 2x minus 3. And again, if you had just taken out the 3, right, you would have seen these didn't match. You would have had to take something else out. So if you didn't recognize that right away, you'd say, hey, these don't match. Then you'd realize you can take out another 3. If you have to do it twice, nothing wrong with that either. So now that they match, I've got x squared plus 9 times 2x minus 3. All right, so these next ones still just say to factor completely. So we're going to be using different methods. We may be factoring out the greatest common factor. It may be a difference of squares. It may be perfect square trinomial, maybe arch method. We're just factoring it down completely, which means that it's in basically 2 parentheses, potentially something else multiplied in front if there's something that we can take out of all the pieces like we were doing early on. Oh, not really early on, but anyways, a few days back when we were doing arch method stuff. So 24. 36a to the 4th minus 4a squared. You done? You just sit right there. All right, so let me back up. Obviously, this doesn't really look like anything. I mean, it kind of does, but there's 2 terms. So I'm going to first of all see if there's something that both terms have in common that I can take out. So is there something I can take?
Squared.
Yep, 4a squared. So I'm going to do 4a squared, and that leaves me with 9a squared minus 1. Now, once I get to this point, then I need to look, is this something that can factor farther? If I'm asking you, the answer is probably yes.
Oh,
Yes.
yes.
Yeah.
The A2. Oh, no,
Maybe
it's A.
3a.
This is something squared, and this is something squared with a minus sign between. So what special type is that?
Negative. No.
Cut her a break. She wasn't here those 2 days.
It's okay.
Grace.
I'm putting an effort.
Grace.
Think about it.
There's 2 special types.
Oh, the square, the
Square.
perfect square
No, he's got the one.
trinomial.
Other one.
Oh,
There's only
the-
2
Difference of
pieces.
squares.
Difference of squares.
Square.
Told you guys.
So this would be the same as 3a squared. 1 obviously is always squared. So I keep this 4a squared out here. Now, this is the first term plus the second term times the first term minus the second term. So this is 3a plus 1 times 3a minus 1. And we keep that 4a squared that I factored out originally. So as far as checking these, we can still check all of these. I haven't really, well, you can check these ones too, but same way. But anyways, but these ones, what I would do first is I would FOIL these back. Then I would multiply everything by this, and you will get back to what you started with right here. Now, technically speaking, this was a difference of squares to begin with. I'm not even going to go there. That's going to confuse you. That was also a difference of squares to begin with before I ever took anything out. But anyways, moving forward. 26. 4y to the 6th minus 16y to the 4th.
Difference of squares.
No. I gotta take something out first. Pretty good hint is that in this section you are pretty much always gonna be taking something out first. So what can I take out?
4
squared.
4 and what else? Y to the 4th. What does that leave me with in this first term?
1y squared.
Y squared. What does it leave me with over here?
Minus 4.
Minus 4. Now, is this something?
Yes.
What is it?
It's like 1 squared and
2 squared.
What job
Difference
is
of
it?
squares.
It's a difference of squares. It's y squared and what squared?
2 squared.
2 squared. So that means that this is going to be 4y to the 4th times first term y plus second term is 2 times y minus 2. Yep. It's 8th grade. Thank you.
What's your favorite horror movie, Ives?
They were trying to catch their breath. They were running out
What's
of
your
breath.
favorite horror movie?
Yes.
They were-
No.
Oh.
That's the QR code specific
They
to each
all their energy out
brochure.
of picking up the phone. They're like,
What's your favorite horror
Megan made them. She can do it pretty quickly. She just has to know.
Another day in our life. Wait a second.
another life.
Another day?
Another life.
Another breath.
How many lives? I think Brent's been through like 13 lives. 13?
That's
Oh
how
no,
old I am.
365 and 13.
That's why
John, they
he
keep you
changes
that math.
personalities every day, dude.
Who made the flyer?
That's fair.
So what about leap years?
Okay, so basically what I would do you have Megan's number? I would just text her and just say, hey, I need a QR code for this amount of money for basketball camp. Now, does the price go up for basketball camp after a certain date like volleyball does? Okay, so she needs to know that date as well because when she sets the QR code on that date, the price will automatically increase. And they will only be able to pay the increased price because we had a problem with that last year with volleyball where people were coming in the day of and were paying the cheaper rate. Which at the end of the day, it's no big deal, no. But there's an incentive to do it early so that we know. And like for us, we don't guarantee a shirt if you sign up after.
I remember there was this one kid. I like the camp that.
Just say Stacy said that you did the QR code for volleyball camp. Would you be able to do one for basketball? This is the price. It goes up to this price after this. And what I did is I actually added on $5, a $5 fee for volleyball to cover the cost of the QR code.
And then they went down to Earth. They invaded the thing. They went home. She had blue hair.
She had white hair.
And
What do you know?
And then she was like, Scotty, beam me up. And she went up.
Guys.
And then she was like, oh, my zombie boyfriend's gonna be down here all alone.
Guys, try this one.
I'm happy that
Yes, ma'am.
I did, but I just did it that way for everybody. So like the cost of was gonna be $60 for like the beginner camp, but I just made it $65. And then, I mean, I really had to do it for the region one so that we cover the cost of everything, but I just did it for all of them to be consistent. So like you may want to go in and have him up the cost by $5, or because it's just money going into the athletics account with those ones, then you just eat the cost. It just doesn't matter. Like she can do an extra $1 fee for using the QR code, so she can just automatically set it to be an extra $1, but I just wanted it to be the exact same for everybody, just so it's easier. And so it's like, because I would rather people just pay the QR code. It's much easier for us all around if they pay it that way. Because then it's not money coming into the office when we're not even in school and all that stuff. I would figure it out because, like, I think that Hunter gets paid. And Hopkins, if he's doing, I think he gets paid. So, like, we don't. All the money from volleyball goes into the volleyball fund so that volleyball can buy equipment. Yeah. Yeah. Because she didn't know what the fee was for the square, and I said, well, $5 cover it, and she said definitely. So, I mean, you may just, you know. Because I don't think basketball can make money.
I actually checked the problem once in my life.
I don't understand anything about this. But somehow
I don't understand 9.3.
Yeah.
9.3.
Because then when he goes to add in the QR code, he can edit the price. I would just say to edit it for everybody. Because also, oh, I just realized there's gonna, because you know the disc, yeah. See, volleyball doesn't have that because it's first. Volleyball gets you a discount on the other ones, but volleyball is just a set price. She may need to do it where on the one QR code they can select the price for the discounted price if they've done volleyball. Well, it can't be done online. Like, they cannot pay online then. Because it's a whole thing. Lisa made it very good. It has to be paid due also. I would just do it, and if somebody really wants the discount, they can pay by check. That's what I would say, if they're that worried about it. Yeah. Because the problem is, I had somebody last year who thought because they paid for soccer first that they just got a discount on volleyball. I was like, I was like, that's not what it says. It says if you pay for volleyball, you get a discount on the other ones, but okay. Okay, bye.
Who was that?
None of your business.
That's right.
Oh, you know what is the question?
Okay, normally I have seniors in here when she calls, and at the end of the day, she never knows which class is in here. But anyways, so she normally calls and she's like, hey. Like, she's like being funny when she calls my room anyways, and because they always laugh. So then I was like, thanks a lot. I have 8th graders right now, like, just being funny.
Is that why she was breathing into the
Yeah.
phone?
Yes. Okay, did we get this right?
Yeah.
Yay.
Awesome.
I
Okay.
actually checked the problem for once in my life.
How do you check?
Let's see. I'm jumping down to 32. Wait. Hold on. 31 first. All right. M squared minus 5m minus 35. All right. How do we factor this?
5.
Find factors of negative 5 would also equal negative 35. Well, no. Factors of negative 35 add to equal negative 5.
So negative 35 that add up to equal negative 5.
We're doing this.
What? No. What?
Yes, solve
Just
it.
tell us.
Solve it.
Solve
I
it.
remember this.
Oh.
I remember this.
Wait.
All right. All right. So 7 and 5, but does that add up to negative 5?
No.
Does 7 break down any
We
farther?
need a
No.
negative 7.
Well, that
Oh,
still
what?
wouldn't add up to negative 5.
No.
Does 5 break down anymore?
2.5.
No.
No.
Does 1 and 35 work?
No.
No. So guess what?
Ooh. Unsolvable.
What? No.
What?
Not factorable.
What?
Yay.
Different.
It's an option.
It's technically been an option the whole time. All of ours have just factored to this point.
So I can write this.
If it's not factorable and you write that on the quiz or the test, you best show me why it's not factorable.
Oh.
Yeah.
Yeah, video.
Look at my desk. You're not that tall.
It's not factorable because I thought of it in my mind.
All right, 32.
He's not.
Wasn't that
6g cubed minus 24g squared plus 24g.
Hang on.
All right, so the first thing I need to do is I need to factor something out. What is the biggest thing out of all 3 pieces I can take out? 6g.
Yeah, 6.
So that leaves me with g squared minus 4g plus 4. Now I'm looking at the stuff in here to factor to see if it can factor any farther. Sometimes it can, sometimes it can't. So, what is this?
It's a perfect square trinomial.
It is a perfect square trinomial because the first term is squared. The last term is something that can be squared. This would be 2 squared. Then this middle term is 2 times the first term times the last term. And that's for, we keep the sign of the middle. So, what does this factor into?
6g is in the front, and it's like g plus 2 squared. G minus 2 squared.
Sign of the middle. G minus 2, all of that squared. Now it is factored completely.
Easy. You did it.
So, Coach Jason, when you do the thing where, like, with the perfect trinomials and you do, like, 2,
Like this, the red.
do you have to do what's, like, for the 4, you have to factor that out and then get 2, so it's 2 times 2 times, instead of, like, 2 times 4 times
2 times 2. Well, it's 2 times the first term times it's whatever's being squared. So, like, it's not really 4, it's 2 squared. So, anytime I say something like the first term and the last term, I'm saying, like, whatever's being squared, that's my first term. It's the first term squared, or last term squared is really what I'm saying. Yeah. Let's see. 34. 3r to the 5th plus 3r to the 4th minus 90r cubed.
Combined with.
Should we take
Actually, no.
3 out. We should take 3 out.
What else?
Oh, there's
A
5.
3
Wait, no, it's
r
not.
3.
3r cubed.
Look at the next one. It's 5.
3r cubed leaves me with r squared plus
You can add them.
r minus 30. Now, can I factor this any farther?
No.
you mean no?
Yes.
Remember what she asked
Just
me?
because it's not a special type doesn't mean that it's not factorable.
Yeah, great.
I need factors of negative 30 that add up to equal 1.
6 and 5.
Negative 6.
Negative 6. No.
Negative 5 and 6.
Negative
Negative 5.
Negative 5 and positive 6, because when I add those together I get a positive 1. So this is 3r cubed times, since this was just a 1 in front, I don't need to write out everything in the longhand form. I can just write r plus 6 and r minus 5. That's my answer.
No need to say it out loud.
R plus 6, R minus 5.
There's no need to scream it out loud.
I'm not that dumb.
Why didn't
I
you
was
listen
sure.
the first time?
Yes.
36.
You want to alpha.
H cubed plus 4h squared minus 25h minus 100. So now there are 4 terms. What did we do earlier when there were 4 terms?
2 terms together.
We factored by grouping, so pairs of 2. So what can I take out of this first group?
H. 2.
H squared. And that leaves me with h plus 4. What can I take out over here?
Negative 25.
Negative 25. That leaves me with h plus 4. Now, I have h plus 4 and h squared minus 25. I need to see if this is factored completely. What is this?
You got it.
It's a
You almost have it.
Square.
It's right there.
It's like a
square.
Difference of squares. So, what would this factor into?
H squared minus 5.
5.
It's not meant to make fun of people who just
H
like-
squared
minus
Well,
5 squared.
that's what the 2 terms are, but what does it factor into?
Come on.
Nice.
Like H plus 5 and H minus 5.
Yes. So, h plus 4. Then this factors into h plus 5 and h minus 5. So, this was really h squared. This is really 5 squared. So, it's h and 5 in both, and the one's positive, one's negative. So, this is my answer.
What?
So, sometimes, like the problems we were looking at earlier on, problems like 13 through 21, where there were 4 terms, they just kind of stopped after we got to this point. It wasn't something we could take farther. But part of factoring completely is seeing, can I go any farther? In this case, I could. And so I did. Um, 38. 2x to the 5th y minus 162x cubed y. So I only have 2 terms here. So the first thing I'm going to do is try to factor something out. That's really the only thing I can do unless I see right away that it's a difference of squares. I can tell right away this is not a difference of squares because they have odd powers. So I'm not saying that it can't be a trinomial. There's not 3 terms. I'm not saying that it can't ultimately be a difference of squares, but as it sits right now, it is not a difference of squares. So is there something I can take out of both pieces?
2x3, x3, y, 2x cubed
Okay,
y.
it's not x3, it's x cubed, or x raised to the 3rd.
I like to speak fast.
Crazy.
Well, you're going to slow down and you're going to say it right.
2x cubed y.
Yes.
You got it.
2x cubed y. That leaves me with x squared minus, what happens when I take 2 out of 162? 81. Took that out, took that away. Now, I have 2x cubed y times x squared minus 81. If I see 2 terms and I see that this is a minus sign, I'm always going to check for a difference of squares. Is this a difference of squares?
Yes.
Okay, because what squared is 81?
9.
Okay, so what would this factor into?
x3, 2x to the 3rd, y, x plus 9, x minus 9.
Yep.
Rudy, shut your trap.
Bro, can you shush?
Oh, really?
You can do
Shut.
this in your head, bro.
Yeah, shut your trap.
You can't do that.
Okay, Grease.
What did I say?
All right, now, much like all the other factoring sections, there are some where you are solving the equation. So I want to look at one or two of these. Let's see, 44. A cubed minus 11a squared minus 9a plus 99 equals 0.
Okay, so we're gonna like maybe group.
Yep.
Or we just don't.
Factor by grouping. What do I take out?
A2.
When you say it right.
A squared.
A squared or a to the second power.
Just page on
Leaves me with a minus 11. What do I take out over here?
No, we said
Negative
cooking
9.
Negative 9, because I know that I need this term to be minus. So negative 9 leaves me with a minus 11. So I've got a squared minus 9 times a minus 11. Now, can I take this any farther?
Yes.
What will it be?
It'd be a plus 3, a minus 3, a minus 11 equals 0.
A
What?
plus 3 times a minus 3. Copy down the a minus 11. And that's all equal to 0. So what I've been having is two terms multiplied, and I was setting each of them equal to 0. Now I have three things being multiplied by each other. All three get set equal to 0. So I've got a plus 3 equals 0, a minus 3 equals 0, and a minus 11 equals 0. So a equals negative 3, a equals positive 3, a equals 11. Those are my three answers there. As a general rule, whatever your highest power is up here is going to be how many zeros, quote unquote, that you have. So how many answers that we're going to have.
3. It wasn't a question.
Now, that's not always 100% the case, but I'm just saying you can't have more, I guess is what I should say, than whatever that is. So if this is a cube term, I can't have more than 3 answers. 46.
I was looking so hard for a point in that problem. It's like, you gotta make a mistake.
5n cubed minus 30n squared plus 40n equals 0.
Take out 5n.
Take out 5n, and that leaves me with n squared minus 6n plus 8 equals 0. Now, I want to see if this can factor.
Negative 4, negative 2 go into 8, else negative 6.
Okay, so it's not a perfect square trinomial then. This isn't a perfect square, so it can't be a perfect square trinomial. So we've got 5n, and you said this is what?
You could do negative 4 and negative 2.
Negative 4, negative 2. Those would multiply, give me a positive 8. They add together to give you negative 6. So n minus 4 and n minus 2. So now, when I set this stuff equal to 0, we've got 5n is equal to 0. We've got n minus 4 equals 0. And I've got n minus 2 equals 0. So I've got n equals 0, n equals 4, and n equals 2. Any questions about this?
So for the part where you like, or it was like the 3 and then you went to the n minus 4 times n minus 2, did you just like factor, so like negative 4
This.
times negative 2 equals positive 8?
Yeah.
Okay.
Because this was factors of 8 that give me negative 6. And they were negative 4, negative 2. All right, problems. 3 through 39, every other odd. We remember what that means, right?
Yeah.
And then 43, 47, and 51.
Oh, okay.
That's
You were
probably
going for
about.
like
Probably about
That
18
wasn't
problems.
bad, okay? I thought it was gonna be like
Probably
43,
about
800.